Today I'm in Houston and going to fulfill one of my dreams. Be an astronaut, but unfortunately I won't be in the spaceship. I will be able to see a mock-up of it from the outside. Hopefully this will be fun.
There's two moments that transit police or whatever, and then the guy that walked out the car and the guy. I was like, why make life so disruptive? Cross over the building. God, mercy. Okay.
I finally reached NASA. It's not that far from middle of Houston, like 25 minutes by car. Now we already paid for our ticket, so we're going in. Let's see. I just gave it myself a stick. Apparently it's not allowed. You give it to them and they give you like a small coupon to get back on the way out. I'm guessing this is the Mars rover. It's much bigger than I thought actually. That's why it costs so many multi-billion dollars. Sorry. Hello. There you go. Thank you. This is the Mars rover. It's much bigger than I thought actually. That's why it costs so many multi-billion dollars. If you guys need to buy a souvenir, that looks like a very big place. This is Apollo and flight garments.
Ever set foot on the moon, but not for long. Before the center of the JSC grant. This area is now used as an educational opportunity for students learning about agriculture. Rice University in 1961. Rice provided. This building also houses the Space Food Systems Laboratory, where scientists develop and process food for space flights. Most food is made from scratch and then freeze-dried or thermostabilized. Since there is no cold storage of food on the station, these scientists have developed more than 100 foods that meet nutrition and palatability requirements and can be stored up to
Like just about everybody. Once again, y'all just do us a favor and please remain quiet throughout the entire presentation. If you do need to.
Now, here at NASA, we don't call it the White Flight Control Room. That's too long. What we call it is the White FICR. You see, FICR is an acronym, FCR, Flight Control Room. And NASA has acronyms for everything. So we call it the White FICR. Now, the white picker is only one of the 5 control rooms that we have in this building. We have the original 2 control rooms on the other side of this building. The brown picker and the green picker, otherwise known as picker 1 and picker 2. Picker 1 actually is the control room we are now using for the International Space Station. And if you look up at that other screen over there, what you will see is the the brown picker 1. They're actually that's actually the screens that you see up there, and I'll get to that in a moment. We also have the blue picker. When you leave today, if you glance over to your left, you will see the blue picker. It's just adjacent to this control room. That's used in conjunction with this control room. Like when we did the Hubble telescope, when we fixed the Hubble telescope, we had some people from the Jet Propulsion Laboratory in California come down here and work with us, and they worked out of the blue picker. And then we have the red picker. The red picker is used for training purposes. That's to train the people who will eventually be working on these cars.
On the right is the employee road. The trees are planted in memory of past employees, families, and other individuals who made noteworthy contributions to the space program. On the left, you see a circle of trees. That oaks is the Astronaut Memorial Road, established for the 10th anniversary of the January 28, 1986 loss of the Space Shuttle Challenger and its crew. Another group of 7 oaks was added after the deaths of the crew of Space Shuttle Columbia. On February Columbia, President George W. Bush came to JSC and spoke these words.
To leave behind Earth and air and gravity is an ancient dream of humanity. For these 7, it was a dream fulfilled. Each of these astronauts had the daring and discipline required of their calling. Each of them knew that great endeavors are inseparable from great risks, and each of them accepted those risks willingly, even joyfully, in the cause of discovery. In the human heart, we are that part of creation which seeks to understand all creation. We find the best among us, send them forth into unmapped darkness, and pray they will return. They go in peace for all mankind, and all mankind is in their dead.
Spaceflight is neither safe nor easy. And while we grieve at the death of an astronaut,
And wait for the next available tram. You do not have to take the same exact tram back. You can take any tram.
Can you go in? Oh wow. That's where, like in those videos, the fire comes out, the combustion engine. Cool. I heard it's like a fake replica, but it looks so real.
Must be outside.
Sorry. 649, 68, 62. Yeah? An asteroid fragment, which is, that's weird, it looks like metal.
Surface and returning them home safely is an enormous challenge. The full round-trip mission will take years to complete. So, the spacecraft, life support, communication, and science systems will need to be self-reliant since support from Earth will be limited. To send a crew to Mars in the next couple decades, NASA is developing new technologies and solving scientific challenges that will inspire and educate the next generation. These new advances will create an even better life here on Earth. So, come join our exciting journey.
The more sensitive way to look at our crops and do that. Got organization for the agenda of space station. So this promise element is the best. Space value is a lot. So we want to do that with the I just gave us a lot of with the work. We're able to get it through we're able to locate these models with my own source and music. So all of the things and we were able to do it.
Wow, they even show us the tools. Awesome. Seriously, it's not just kids a toilet. Ooh, M&M's. Spaghetti, anyone?
That is isolation.
It is kind of copying my face. I can move the mouse with my eyes. These are controlled by some kids up there.
Which one's heavier, man? Which one?
Water we buy here and drink. You just have to get over the mental hang-ups, which are the hardest part. Having a closed loop system will allow us to travel farther in space. We're already using this technology here on Earth too, not just to recycle water, but also to purify water to save lives. All right, Henry, you just used the facilities, so you need to wash your hands. Get your hands good and clean there. There you go. Since water is so precious on the station, they use antibacterial hand wipes, full-size wipes on their bodies, and a shampoo developed by NASA called No Rinse Shampoo. They do look forward to having a real shower when they get back home, though, because they miss those a lot. Henry, I will take that from you whenever you're done. Thank you, sir. All right, Henry, now I'd like for you to come with me down here to the galley area. See, this is where you'd be hanging out with your fellow astronauts, just floating around, talking about your day. We're on the International Space Station right now, aren't we? Yes, we are. So since we're on the space station, Henry, where does the water come from that we're adding to our tasty foods and drinks? You think you don't know, but you do. You're blocking it from your mind. Let's see. I got a young man with a big T on his cap in the back row. No, you can just stay there, sir. Just stay there. Where does the water come from? You know? No? Right here, the young lady? That's exactly right. Recycle pee! Just have water and enjoy. Oh boy, thank you for that. Of course, on the station, everything goes floating around. So they put Velcro on all the food packages. It's also on their clothing. My favorite part about that is it means that you can get all your meals to go. How cool is that, right? Yeah, not bad. Okay, Henry, you have demonstrated sleeping, exercising, going to the bathroom, personal hygiene, and food preparation. There's more to your training today, Henry. The International Space Station is not just a place to live. It's a space laboratory for new kinds of research that's impossible to conduct in gravity on Earth. And Henry, you're going to demonstrate how some of this research is done. Come stand right here for me, please, sir. Stand right there. Yes, sir. Turn around and face everybody. There you go. Put your arms to your side. That's it. Look straight ahead. Look that way. Perfect. And Henry, very important. Don't move. Be very still. I'm going to scan your body. You are very brave, and you're doing an excellent job. Don't move. I got to decide. This does not hurt at all, but it does leave a small permanent mark. I'm done. You okay? I'm glad you're okay, Henry, but you know what? You probably should check yourself out because I never know where that mark's going to be. You know what? You might find it later. Yeah. Oh my goodness, Henry, look at that. You did a fabulous job. It came out great. Thank you. Come on over here with me, Henry. What I need you to do now is go down the steps and go back to your seat. And the reason I'm sending you down is because from down there you can see a lot better what we're doing with your body scan. So careful going down there and just push on that gate and it'll open up. But Henry, you're not finished yet, okay? You have to keep paying attention because you're still in training. All right, while the system is processing Henry's body scan, I think I need to have a sip of this refreshing recycled water. All this talking makes me a little thirsty. Excuse me a second, I have to undo the straw. Tangy. Of course, here on Earth, gravity keeps this tasty beverage inside the pouch. But if you take gravity away, I'll show you what happens. You see, with gravity gone, surface tension becomes the dominant force. And notice, when two blobs of water collide, they merge into each other, forming a bigger blob. Physics appears to behave differently in microgravity. And then when it hits an absorptive surface like that towel over there, a wicking action pulls it into the towel like a sponge. Well, cheers. Henry, what do you think? You think your body scan's about ready? You think I should go check on that? Yeah? Okay, let me see if it's ready here. There we go. Now here's what happens when astronauts like Henry travel in microgravity. The fluids in your body move up from your arms and legs. This makes your face puffy and your legs thin. This condition has a highly technical name, very scientific. It is called chicken legs. Your bones lose calcium and your spine expands up to 2 inches. Also, in microgravity, your heart shrinks a little bit. Now, Henry, don't worry about that too much, okay? Because once you get back to Earth, your heart gradually returns to normal. But as to the calcium loss and some other things, recovery is a bit more difficult. And that is why our astronauts like Henry are such willing test subjects, helping us to understand how microgravity will affect future long-distance space travelers. In other words, before we can send humans to Mars, we will have to invent a way to prevent osteoporosis. Biological processes aren't the only things that are different in microgravity. Chemical reactions behave differently too. In fact, I want to show you something else. Look at this. Ooh, hang on a second. Here we go. Now, notice how a simple candle flame burns here on Earth. You see the shape of the flame? It burns in a teardrop shape. Well, did you ever wonder why? The fire makes the air hot. The hot air rises. So this causes cooler air to rush in to take its place. This process is called convection. And it is what gives flames here on Earth the shape that they have, rounded at the bottom and pointed at the top. But in microgravity, heat cannot rise, so there's no convection, no airflow. Well then, what does it do? As you can see, it burns in the shape of a globe instead of like that. And get this, it burns more completely, much cleaner, and more efficiently. Having a laboratory in microgravity will allow us to find out why it does this and how we can get it to do this here on Earth. This is important for future engine designs. Our microgravity research on the physics of combustion will lead us to more efficient fuels and less pollution. So as you can see, microgravity is an excellent environment for conducting experiments that we just cannot do here on Earth. I have another example for you too. Here on Earth, it is difficult to combine large amounts of lead and tin. And that is because the lead is heavier than the tin is. So the lead sinks to the bottom. The tin rises to the top. They keep trying to separate like oil and water. But in microgravity, fluids with different densities can be mixed together almost completely. And in this case, it'll lead to improved manufacturing processes here on Earth, resulting in a more stable alloy with fewer flaws. The International Space Station is also a unique laboratory for medical research and development. So let's just say that you are a scientist here on Earth, and you're studying a really nasty bug or disease. You would have to grow lots of cells to experiment with. Well, the problem is, in gravity, living cells that are grown outside the human body cannot grow very large before their own weight crushes them and they die. But cells grown in microgravity thrive. They grow bigger, larger, and in 3 dimensions. This is a huge medical breakthrough. We can now grow large quantities of cells, and the data can be studied by scientists here on Earth. And in the coming years, you can expect to see developments in disease control, genetics, biochemistry, and organ transplants, all because of our microgravity laboratory. Who knows what we're going to discover next? As you can see, the International Space Station is already improving our lives here on Earth right now. But what it has to offer our future is even more exciting. The ISS is a stepping stone in our journeys off the planet, beyond lower Earth's orbit. No doubt we will return to the moon, and one day even go to an asteroid. And in the late 2030s, we're going to send humans to Mars. And after that, it's on to the stars and beyond. And I know we have some future explorers in the audience right now, too. Henry, you have one more very important thing to do. You ready? You're going to like this. I need you to come stand right down here for me, please. Stand right down there. Yes, sir. Turn around, face your body. Ladies and gentlemen, let's have a big round of applause for our new astronaut. Henry, you did a great job, and I'm going to come down in just a minute and give you a special gift for completing your training. To find out more about the ISS, check out the exhibits behind you in there and on the other side of the wall behind me. When you go around back there, don't forget to look up. Thank you for joining us here. Enjoy the rest of your stay at Space Center Houston.
Colton. All right, Colton. I want you to meet your audience. Audience, meet Colton. Hello. Now, Colton, the audience does not know it. They need you to help. Can you help them out today? All right, now they're going to need you to check things out. Colton, I've got a cup here. And my cup says H2O. That's the molecular structure of water. So Colton, that makes this my water cup. So you need to take my water cup, check it out, see if it's empty. Is it empty? Is it clean? All right, I want you to show it to the audience. Turn it like this so they can see. Now turn it to everybody. Show it all of them. There you go. All right, now turn it upside down. There you go. Shake it up and down. Hey, Colton, do the hokey pokey. All right. Now, Colton, I'm going to take my cup back. Give you another one. I want you to be careful. It's got a liquid in there. Don't spill that liquid, okay? That liquid's important to me because that's my drinking water. I'm going to touch it with my finger, Colton. We're going to try to splash a little bit of it out there on our audience so that they know that we got some water in there. So, Colton, do you have water in your cup? How do you know it's water? Looks like water, don't it? Yeah, okay. I want you to pour that water into my drinking cup. There you go. All right, I want you to look to your audience. Look out that way. Now take a bow. They're going to give you a big round of applause. You can get back to your seat now. Thank you, Colton. All right. We're going to get to that in just a minute. All right, guys. While Colton's headed back to his seat, I'm going to open my straw so I can drink the water that Colton has prepared for me. Colton, I thought you put me some water in my cup. Did you pour the water in there? Did you pour me some water in here? Didn't you pour water in there? There's not nothing in there, Colton. What did you do with my water? You drank my water? No, I didn't drink it. What happened to it? Hey guys, you want to know what happened? When you weren't looking, I snuck a contaminant into the cup. I put something in there called a super hydrophilic polymer. Now, that's a long fancy name for something the kids love to play with called super soakers. Now guys, if you go to the store and you get yourself some of these super soakers and you drop them down into a jar of water, what happens to them? Yeah, they get bigger because they love to drink the water. So when you weren't looking, I used my straw and I snuck some of that polymer into the cup. Then when Colton poured the water in there, it turned it into a gel. Now this is the same substance that we mix with cotton and it's used in disposable diapers. That way when the baby wets, it absorbs all the liquid. So moms and dads, now you know why every time you go to change a diaper, hey, that's an FYI. What's an FYI? For your information. And for your information, I have one rule here at my lab. That rule is if you know the answer to a question, I need you to please yell it out as loudly as possible. Do not sit there and raise your hand and wait on me to call on you. I'm not going to. Just scream out that answer, all right? And adults, guess what? Let me rewind that and try that again. Hey adults, guess what? What? You're now all kids. So that rule applies to you guys as well because this show requires audience participation. Alright, it is time to start the show. And did you know that right now every one of us has about 15 pounds per square inch of air pressure pressing down on our bodies? Now, can we feel it? No, we can't feel it because we live here on Earth. And on Earth we have something called an atmosphere. Now what that means is you've got the same amount of air pressing out of your body as you do pressing down on it. That's because air pressure loves to be equal. Did you hear what I just said? Air pressure loves to be equal. That's right guys, and today we're going to prove that we have air pressure here on Earth. In order to do that, I'm going to need 2 volunteers from the audience. Now these volunteers have to have really strong lungs. Alright, I'm going to use the little lady in the glasses right there. You had your hand up, right? Alright, I need one more.
I haven't either.
I'm going to go with the Indian right there. Yes, go ahead and come up on the steps for me. All right, so. Guys, I've got 2 bottles on my countertop. I need you to choose a bottle. I don't care which one of you grabs first. Just grab one and we'll go. Alright, I need one of you to stand on this line right here, the other one on that line. Alright, hold your bottle out in front of you like so. Slowly move it in front of the entire audience, just like you were Vanna White. Alright guys out there in the audience, tell us what's in those bottles. Hey guys, today we're going to have an old-fashioned race. I want to see which one of you two can blow up your balloon the quickest. Who's got the most hot air? And do you understand what to do? You understand what to do. On your mark, get set, go! Start blowing those balloons! Blow hard!
Come on, Tori, blow harder!
That's good. Let's see what you got.
Sorry. Oh, yeah.
You were supposed to let the girl win. Hey, what happened? You could have blown in your balloon all day long and you would have never gotten it blown up. You know why? It's already full. It's full of air. Yeah, it's like having a jar full of candy. If you had a jar full of candy, could you put more candy in that jar? No, it's already full. But what if we had a hole in the bottom of our jar and the candy fell out the bottom? Could we put more candy then? Yeah, and that's what happened with this bottle. We had a hole in the bottom. So when you blew into your balloon, the air pressure pushed all the air out of the bottle, leaving more room for that balloon to expand, proving to us that we do have air pressure here on Earth. So guys, you both did exactly what you were supposed to do. Now I need you to look to your audience, raise your right hand high. I need every kid in the audience to raise your right hand high and repeat after me. I will always do everything my mama tells me to do. Give them a big round of applause, guys. Was it interesting? No? It's okay. I mean, you got one of the big rockets inside of it. You look at training facility.
How's the tram?
That's okay. You know, then she got wet and then he turned.
Wish me luck.
In front of you. And an emergency stop button is located overhead if needed.
Don't put your face there, yeah.
Because it's going to be bumpy.
Oh, see, we're moving up.
Technology, innovation, and the will of the human spirit have led us to one of the most pivotal moments in history. Today, we leave the safety of our planet and embark on a journey through the universe.
Main engine start. Main engine start. 2, 1. Booster ignition. We have liftoff of the Galactic Traveler on the first mission to rendezvous with a black hole.
What?
All systems nominal.
Woo!
Good burn.
Instrumentation testing is a go. We are showing successful deployment.
Passing through the solar system, we see the perpetually active storm on Jupiter. The Earth could easily fit inside of it.
Approaching
Approaching Enceladus.
Volcanic ice, ejected from one of Saturn's moons, helps sustain its awe-inspiring rings.
Prepare for near light speed travel as we plunge into the heart of our galaxy, the Milky Way. Approaching Alpha Centauri.
This is a nebula, a kind of nursery where stars are born. Enormous gravitational forces condense vast quantities of hydrogen gas into smaller and tighter spheres. The compressed hydrogen fuses together, igniting and creating a star. Smaller parts of the gaseous cloud cool and collide with each other, eventually becoming planets. Millennia after their formation, stars run out of fuel and collapse, sometimes creating a black hole, but not before shedding their outer layers.
Approaching Sagittarius A star.
There it is, the massive black hole at our galactic center. Sagittarius A star has the mass of 4 million suns and is consuming stars and gas at an enormous rate. It too was formed when a supermassive star collapsed. It has so much gravity that not even light can escape its pull.
Warning. Event horizon.
That planet has strayed too close to the event horizon, the gravitational point of no return. Our trajectories are changing. We're too close. Fire all thrusters.
Initiate reboot sequence. Fuel level critical.
Whew, that was too close. Wow. Some astronomers estimate that there are more stars in the observable universe than there are grains of sand on Earth. The billions of galaxies we see are held together by a mysterious substance called dark matter. Yet strangely, they move apart, pushed by another curious substance called dark energy.
My day at Houston Space Center was awesome. Just honestly, you don't need the full day unless you want to see every show. I've seen most of them in like 5 hours here. Nah, 4.5. It's more than enough, and well, if you have kids, yeah, you need more than that.